All right, guys, welcome to another KevCAM night class tonight. I just want to welcome everybody back and anybody that is new to the night class. Tonight we will be covering HSM boundary machining and offset cutting. So some pretty interesting tool paths inside HSM, and we're going to be kind of going through some more HSM throughout the weeks and then slowly move into HSS. But for those of you guys that are new to the night class, currently everybody is in mute. That's just to eliminate any background noise. If you guys do have questions though, and I definitely encourage you guys to ask them, there is a questions panel in the GoToMeeting or the GoToWebinar control panel. So definitely guys, if you guys have questions, ask them away. These classes are solely dedicated for you guys. And that being said, for the guys that are new in here, if you guys do have ideas, please email those over to me and we will actually send you off some SolidCAM swag. So send me your ideas, and for those of you guys that don't have my email address, let me just put it into the chat for you guys. All right, so I put my email address in there for you guys. You guys should all be able to see that right now. And for those of you guys that are new too, we also, all the night classes are put on my YouTube channel. Definitely go there, check it out. I will put the link in there also. Let me just get this copied for you guys. Paste that. Definitely go there and subscribe. I'll pull it up for you guys here. So in here, I have tons and tons. I think we're up to like 94 videos now of tips and tricks inside SolidCAM. Quick little videos to our, the night class videos. So everything in between. And like I said, with your guys' ideas, we keep adding more and more in there. So definitely come in here, check it out. If you guys are a little bit new to YouTube, if you guys just go to my channel, and then if you're looking for something specific, just click the little search icon inside the channel. So, and it kind of got pointed out to me a few weeks ago, and I kind of forgot about it, that signing up for the night classes was kind of taken away off the website. It was kind of hard to get to. So if you guys want, you guys can come to the main SolidCAM page, and then under webinars, you'll see where it says KevCAM Night School. And that's where you guys can register if you guys aren't getting the link sent to you via email anymore, or if you're having to ask, for the link. So definitely, it's for some reason it did get taken down, but it is back up there, and you can see all the classes that are coming up here. Or if you guys missed a night class, it'll take you right to the YouTube channel. So, all right. With that being said, thanks again for joining me on a Wednesday night here, and we'll get heading into the HSM. Okay, so first what we're going to talk about is the offset cutting. Basically, offset cutting is pretty similar to how the morphed cutting works. Now, you guys remember last week we have our part right here, and we did a morphed machining, and this was actually curved. Basically, the opposite way is this one. And what the morph did is we just picked the guide curve on the one side and the other side, and the tool path kind of corrected itself and then followed the form around. Well, we're basically doing that exact same thing again here, but if you have a curved surfaces that are the same, so we have this, curve right here, and we have a curve right here, and we want our tool path to follow along right there, that's where we're going to use the offset cutting. Real easy to use, kind of the same setup as the morph cutting, but just a little bit different. So, we'll see that we already have the part already probed up here. Did a 3DI machining and a HSM linear. And now we'll get into the offset cutting. And this is unfortunately the only part I have for the offset cutting, just because it's kind of tough to come up with parts that have the offset cutting there. Now, is everybody able to hear me all right? For some reason I'm getting like a echo feedback in my headset. Okay, thanks, Clarence. Okay, so we'll start off, come in here, and we'll add our 3D HSM, and we will do our offset cutting. Now, Same as all our HSM operations. I'm not going to kind of go through the nitty-gritty of all these because these are all going to be the same as before. If you guys do have questions, what every one of these buttons do right here, definitely check out the first HSM series on there. And then what I did also with the HSM series is I created a playlist inside of YouTube. So you guys, once we get everything through there, it'll have a complete playlist of everything in HSM. We'll do a playlist of everything in HSS and so on and so forth. So, okay, so we'll grab our tool. And we'll just go with, 375 ball and mill looks good. Now, our drive boundary. Basically, what curve do you want it to follow? So I could click on the right side and follow the bottom, or I can click on the left side. So what I'll do is I'll just hit the new piece of paper here. And that's the curve that I want it to follow. So it's just basically, doesn't matter top or bottom. It's just going to follow that line that you selected as your curve. So your tool path will actually swing along with that curve right there. Now we can do a clear direction in the left, right, or I can actually go both ways. For this one, I'm going to go to the right of that line. So I'm just going to start on from the left and just work my way to the right side. Tool side we'll leave at centered. Now, your constraint boundaries. Where do we want to constrain that that geometry to? Where do we want to limit that boundary so we're not machining, off in la-la land here? So what we'll do is just chain our bottom or top, it really doesn't matter. We'll do our constant Z propagation here. And we'll also leave that as centered. So pretty easy setup so far. Now, passes. And like I've said before, with any time you guys are doing HSM or HSS, leave your step over large to begin with. There's no point in tightening this up really tight, sitting around waiting for it to calculate when we really don't know what our toolpath looks like. So for right now, we'll just leave that large. Now, since I picked right, I want to pick my right clear offset. And I can manually type a number in there, or if I'm just not sure, I can just click it, and we'll just click on the farthest point that I can get at. So we'll see we're at 3.977. Now, let me just try something real quick. If I highlight this, instead of having to click the button, see if you guys a step here. No. So some of our fields do, if you guys highlight this, it will automatically populate for you. And if you guys want, you guys can actually round that number off because it's basically not going past our number right there just because we defined our boundary. So we told it to stay within that boundary. From right there, we can do a save and calculate. And let's see what we have for toolpath here. So a little tough to see with the links in there, so let me just clean up that and we'll just do a bidirectional. So I'm going to go to my passes, turn on bidirectional, basically doing a zigzag pattern. And now we have some nice clean toolpath, just doing nice loops going all the way around. So you'll see, if I get a top-down picture of what's going on here, my toolpath is actually following that guide curve of what we told it. So we basically told it to start over here, move to the right all the way up to this endpoint right here, staying within that boundary of my constraint boundary box that I'd chosen. Now, if we just go ahead and do a simulate here, we can kind of see we have it roughed out and everything. And you can kind of see, with the scallops right there, they're following the same contour there. So I like my toolpath, how everything looks. Everything's set how I want it right now. So now what I can do is I can come in here and tighten up my passes. So it all depends on what finish you guys are looking for, but we'll just do a 10 thou step over. If you guys want, you guys do have the option to do the scallop. So we can have a scallop height, or we can just do step over, save and calculate. and now we have our nice tool path going along there. And like I said, I really urge you guys to, keep that step over large at first with the default value. Get your tool path put on there and see what things are looking like first before you go in and tighten everything up. Because as you can see right now, we have tons of lines in there. It's pretty tough to see what's actually going on. So, I mean, to really get in there, we have to kind of zoom in and see what's going on there. But from right here, like I said, starting on the the left side, moving our way to the right, following that guide curve geometry right there. So we do a simulate here. Now I do have my simulation set pretty loose right now. Let's see what we have it set at. Yeah, we're at 5,000. So it's not going to look as pretty, but it's going to machine it much faster for you guys, so we're not sitting around waiting. And the real nice thing with this offset cutting is it really eliminates a lot of air movement also, so we're not getting a lot of repositioning, not getting any air cutting, and just following that contour all the way around. Any questions with the offset cutting? Like I said, unfortunately, this is the only part I could really kind of come up with that was good for offset cutting. It's a little tough to come up with some of these tool paths on, the best way that they're going to come out for you guys. But any questions so far with the offset cutting here? All right. So that's pretty much offset cutting in a nutshell right there. And like you said, we still have all of our, you can edit your passes, we can offset our surfaces, you can change up your cutting order. You can do none, before, after. You can do an axial offset. So it's pretty much the same thing as what you guys are used to seeing. And then you have your links, how do you want to approach it? If you guys want straight lines, let me get zoomed in here. If you guys want straight lines instead of the spline, you can just do that. Get straight movements. The only thing I really like using these splines just because you get a real smooth machine flow going from one. So now when you're doing the straight line, you're going to have, moving straight down in Y, you have that hard jerk over in X and then going back in Y, where if you have the spline doing a nice arc going around there and keep that machine flowing nice and smooth without any jerkiness at all. So like I said, if you guys have any questions with this, definitely check out that first HSM one that we did with, I think it was Constant Z and Hybrid Constant Z, and I kind of went through what all these do for you guys. So, all right, perfect. So now the next thing I want to talk about is the boundary machining. Boundary machining is basically just kind of doing like a trim pass. All you have to do is specify a boundary to keep it within, and it's basically it's used real nice for we'll use it actually on this chamfer around the edge right here. We'll do a chamfer on a 5-axis part, and then we'll do a chamfer on another part here. And you can also use it for engraving, and we'll kind of cover all that there. But like I said, it's a strategy that creates a toolpath by projecting the defined dry boundaries on the model. So like I said, what we'll do is, well, here, we'll just do one real quick. Do our 3D HSM. And we'll do our boundary cutting. And as I'm kind of going through all these options in here, we were on offset cutting. Notice the pictures change. So it gives you a good representation of what's going on. So offset cutting basically kind of had that highlighted curve right there, and it's going to follow that curve. And when we go to the boundary machining, it's basically kind of doing like a trim pass all the way around the outside boundary. Good for deburring, especially on a 3D contour, just because even if we try to throw a deburring on, on an angle here, we can use the 3D contour, but we're not going to get as nice of a finish as if we're using HSM. So, okay, so let's grab just a spot drill and the dry boundary. Where do you want it to follow, I guess you could say. So I'm going to do a new boundary, and I'm just going to pick the outside edge here. And we'll leave that tool centered. Now, constraint boundary is basically where do you want to constrain it to. I'm just going to constrain it to the entire part. And since I told it what boundary to cut on right there, I really shouldn't have to mess with this one. Now, passes. Basically, how far down do you want it to go? Now, since this one already has a chamfer on there, it's going to go right to size. So it's going to follow that chamfer all the way around. So if we just do a save and calculate here. Now, when we get to a part that doesn't have a chamfer on there and we're basically just looking for a nice edge break going around there, that's where you go to put your wall offset. So what we would do is we'd actually put a negative floor or wall offset in there, and that would populate that chamfer for you. So let me just slow this. Let me change my settings here so you guys can see it without buzzing through it so fast. I'll change that to 1. And if you guys are curious on what I'm doing here, this is just the simulation settings. Basically, I'm telling it to show every single step, where before I was telling it to show every 50 steps. Right? And what you have to do is just exit out and then get back in to kind of get everything reset. Okay. And slow it down for you guys. And just throwing that chamfer on there. Now, one thing I am noticing here is I am going the wrong direction. So let me just come in here, and we'll just do an edit, and we'll just reverse that chain. Save and calculate. Nope. Nope. I'm going to make a liar out of me in my classes here. Let's go to got that on centered auto. This looks all good here. What am I missing? Sorry guys, I try to do these off the cuff so you guys can actually see what it goes into doing a part here, but might have gotten one where should be able to go, oh here, let's just do reverse. There we go. Throwing that chamfer all the way around. So we basically have a nice finished off part here, following that guide curve with that offset cutting there, and then doing a boundary cut, just kind of going around the outside. Now, I totally understand you guys, we can use this, for our, doing a profile. I mean, more than enough ways to do this, this outside chamfer here, but once we get into this 5-axis part, you'll kind of see where it really comes in handy. If you guys want, we can play this through in machine sim. And actually, let me just exit out and we'll play everything through so you guys can kind of get a good idea what we all did on this particular part here. Okay, so we're playing this through on the Haas UMC here. 750. Kind of get in there. Probing up our part. Getting our Y. Doing another X hit. Find the center of our part. Taking the Z hit. Doing a 3D eye machining, getting that roughed out in there. See it a little bit better that way for you guys. Now we're going to do our HSM horizontal, pick up all those flat areas. Any questions on this part before we jump to the next part, guys? And looks like when I was done with my HSM boundary, my machine's not going up. So the great joys of having a machine sim. Obviously I have to do a quick post change there, but nice thing about having that machine sim. So, but all right, so got our boundary cut, did the HSM offset cutting. Let's go ahead and get into another part here. Okay, so I have a pretty kind of funky part here. You know, a little bit of 5-axis work going around the outside edge. We won't cover that today, but kind of wanted to show how the boundary cut works, you know, on a 3D surface. So, you know, pretty easy. Kind of like what I showed last time here. So what we'll do is we'll just do another 3D HSM, and we'll leave it on boundary. We'll go ahead and grab a spot drill here. Now, like I said before, basically what area do we want to cut on? So if we just hit new, got our outside boundary there, and we can leave that uncentered. There's no reason to go past at all there. We'll leave it to the, you know, the outside perimeter area, and now we can go in and put, you know, how much do we want to cut in. So let's just say that we want to do, you know, let's just go let's just do a 50 thou here, and we can just do a save and calculate. Now, before I go ahead and play this through, I'm actually do a simulation here to make sure I don't have this tolerance set super tight. Yeah, let's just loosen that up just a little to the default settings real quick. And that looks good. And let's just play everything that we have done so far so you guys can kind of see what I did here. Doing a 3D eye machining, getting most of our material roughed out there. And then this particular one, I just did a HSS operation. And it's going to show up just a little bit rougher here just because I did set my tolerance a little bit higher, you know, and the accuracy. And like I said before, you know, the accuracy is just the accuracy of your solid verify of what you're seeing right here. Now, the tighter you tighten that up, the, you know, the nicer your part's going to look inside here, but it's going to take just a little bit longer to do the verification. So, and once we get going around here, I'll try to slow this down in time. And you can see that you know, taper end mill, or, you know, if you guys are just using a spot drill, is going in following the contour of that surface all the way around. So pretty nice feature in there. You know, we have a pretty heavy chamfer on there right now. You know, obviously if you guys are just doing a small little deburr, you just put, you know, maybe a 5 thou or even a 10 thou chamfer in there. Just wanted a nice heavy one so you guys can kind of see what's going on there, and the kind of how the boundary works. So now what I'm going to do here is, you know, if I do a side view here, you can see I have my SolidCAM text up on a different plane right here, and you can really see the wave of this part. I'm trying to get a good view for you guys here of kind of how wavy this part actually is, fully surfaced here. So what I'm going to basically do now is I'm going to do the boundary machining to engrave my SolidCAM following the contour of that surface. We can definitely do this in two different ways. We can do it in, you know, 3D engraving, or we can do it with our HSM boundary also. So we'll just go ahead and create a 3D HSM. We'll grab that same cutter. Actually, what I could have done is just did a save and copy, but okay. For our geometry now, I'm going to do our multi-chain, and since it was a text in SOLIDWORKS, I can take advantage of that. Got all my geometry, and we'll just leave it on center like we normally do. Gonna leave it on my auto for the constraint boundaries. You know, where does the outside boundary containing it to? And my passes here, I'll just put a, let's just do a minus 10 thou. Save and calculate. And if we do a simulate here, and we get a nice even 10 thou going all the way around that entire surface. And I mean, you can see all the waves. Now, like I said, take it with a grain of salt here. It does look pretty choppy in there right now, but that's just because I do have my settings set pretty loose for you guys. And instead of making you guys wait for everything to update here, it's kind of a little bit faster for you guys here. But you can see we got a nice clean, crisp, you know, SolidCAM engrave on the center there. Like I said, you guys can use that with, you know, the 3D engraving also. So, any questions with this particular part? We have another one that we are actually going to do a boundary machining on. And it was actually a customer's part that was sent in, so kind of cool to get some other parts that someone else drew up besides myself. But any questions on this, guys? Okay. Let's go ahead and hop out of here real quick. And okay. Now, this particular part right here, pretty much have it all machined here, but the big kicker here is this outside taper. Now, one thing I kind of ran into with the customer is he wanted to kind of go along and use the side of the end mill if I get a straight down shot here for you guys, use the side of the end mill to come up here and then start cutting into the radius again down here, or the chamfer. So a little bit tricky, but this is exactly what the HSM boundary cut was kind of meant for here. So just trying to give you guys a good views on, seeing it here. Maybe just, I don't want to suppress it because I'll probably lose my model here. Let me see if I can, there we go. So you can kind of see we got it straight up and down wall right there with our 45, and basically kind of want to follow that all the way around. So what we'll do here is do our boundary machining. And this particular one, I want to use Mac 1 pause 2. Make sure that's right. Yep. And we'll go ahead and grab our tool here. And we'll use this taper mill. Now, I'm going to come back to these diameters here in a little bit. And that's where we're kind of get for our, we're going to have to do a little bit of offsetting on this particular part. So, so our boundary, what am I missing here? I'm going to grab our outside chamfer here, constant Z. Now, I'm going to leave that at center right now, but you'll see what, it's actually kind of auto-populating here. The offset is basically half the cutter diameter. So I'm coming in here, let me just get my tool here, coming in here and can get a better view for you guys. Kind of coming in here centered, and I actually want to offset it out. So it's going to be riding right a little bit above that edge right there. So I'll just leave it at that, half that diameter. And like I said, so as that cutter's coming around, let me get this positioned right here. As this cutter's coming around, I can't get it. It's going to actually dip down, cut with the side, and then kind of dip back up to compensate for that. So now I'm going to leave our constraint boundaries. We'll just leave it on automatic here. And I want to keep it external of, let's just try an inch real quick. And passes, I think we should be good here because we're following, we already have the chamfer drawn in there, so we shouldn't have to touch any of our wall offset. So if we do save and calculate now, and do a solid verify here. Now, one thing I did create a quick little video for, I think it was last week sometime. See how we have our stock, or basically our slugs sitting there? If you guys don't want those there, what you guys can do is click, I'll have to play it through here. Click this little icon right here, and you might just have to do one single step to get everything active. Click on that, and then you can actually come in here and click on what you want to keep. So, if you guys don't want to see those slugs right there, I can kind of come in here and delete that one. Delete that one. And we can just exit. Now I've gotten rid of those slugs in there. So that's one way of doing it. And another way is you guys can just create a quick little dummy program to get rid of those slugs. And then you can just suppress the G code so it doesn't ever show you guys when you actually post it out on the code. Okay. And that is not what I'm looking for here. What am I missing? Let's see, top edge. And we're going centered. 685. Oops. Come in here and all right, this is looking better here. So I still have a little bit of a notch right here. Give me 1 second here. We'll tighten up our tolerance here. I'm trying to think, what am I missing here? Maybe if I tighten up our tolerance here. Oh, it might be my actual tolerance of my solid verify. It's throwing us off here. All right, let's go ahead and do a solid verify. Accuracy. Well, we're set pretty tight there. Oh, you know what it might be? I'm going the wrong direction here. Let's do reverse. And we're still going the wrong way here. Sorry about this, guys. Let me just do a edit, and let's reverse our chain so it's going the correct way. We're still going the wrong way here. Okay, let's go to passes. Boy, for the life of me, I cannot figure out why we're going the wrong direction here. If we do mill down, nope, we're still going the wrong way here. What am I missing? Passes, that looks good. Nope. Okay. External. Boy, I might be stumped on this one, guys. I might have to get back to you on this one. I just did it with the part 2. Okay, give me 1 second here. Let me try something. And get it spun around the right way here. Now we're going the right way. Okay, what did we do wrong here? Got that contour. 685. External passes. Oh, I had optimized lead position turned on. I think that's what was throwing us off here. So I had to reverse it here, but now we're going the proper direction here. And like I was showing you guys, as it's coming around here, it's kind of coming out, cutting with the side of the cutter, and then coming back up around this spot right here. So let me just turn that back on and see if that's what was our culprit here. You can see, no, that's going the right way. Boy, I'm just not sure what I checked on that first time. To get that to go the wrong way. And yeah, boy, I'm just a little stumped here, guys. So if you guys could see in my webcam, I'd be sweating right now. But any questions with this particular part right here? I see we got a couple questions here. What if you change the dry boundary versus the tool relationship? We could change if we, like right now, we're doing, we could say, well, I'm not, I had to keep it on centered, George, and just do a half the tool to cut it over. Now, if I did external and did 0, we're not going to get the same kind of path. If I just do 0 here, least I don't think we will. Yeah, so we're kind of up and just the tip is just barely touching right there. So for this particular one, then what we would have to do, George, is come into our passes and put a negative wall offset of what that value is there. So that's why I kind of left it on my drive as centered, and then I just did the 685, or basically half the cutter, a little bit, more. And now everything should stay the same. Yep. So that, I mean, you really, with this particular one, since I already had the, the actual angle in there, plus with this, the straight vertical wall right here, that's basically what I found the only way of doing that. And I mean, just get, so that's where it looks like there. Jordan, you were using contour 2 at first also. Boundary was originally set to contour 2. Okay. Let's just take a look here. What do we have? Contour. Let's just do a show. Okay, my contour 1 is right there. And let's switch it over to contour 2 here. Now, how many of you guys were laughing while I'm sitting there struggling through this? All right, let's see if we can, oh, no, we need to click it again. Simulate. Yeah, we're still going the right direction. I must have just had something turned off here, or something wasn't checked. Well, thanks, guys. Appreciate it. So, kind of in a nutshell, a little bit shorter tonight too, but that's kind of with the boundary cutting and the offset cutting. Let's see. We did have one here. I was thinking to see what the difference was, boundary type versus auto manual. Well, George, what he said is, I think I see what the difference was, boundary type auto versus manual. Well, I created a manual one for my drive, and my constraint boundary, I just kind of left it to the entire stock right here. And even if I switched it to, a target, I should still get same results here. But George, you might be onto something, so we'll just take a peek here. No, we're still good there. So, and that second one, guys, is just basically where do you want to kind of constrain it to. The drive is, and this kind of goes for HSS and 3D milling and HSM. Anytime you guys have drive, when it's asking for a drive boundary, a drive surface, the drive is what areas, basically asking you what areas do you want to cut. So what we did is we told it we want to cut this profile line going all the way around here, but contain it to the target model is what we kind of picked right here. Or you can do of the stock model, so it will kind of go past out. But on something like this, really doesn't matter at all, just because we told it to follow along that surface, and kind of keep it within that area. So, so it shouldn't really matter there, George. And I think hopefully that's what you're talking about. Okay. Any other questions, guys, or anything else that you guys want to see done? Like I said, there's not much to this, but the boundary is a real nice spot to, if you guys do have a part more or less kind of, if we get back to Tools, SolidCAM, this part? Nope, sorry, I just pulled up the wrong part. Close this guy down. and this part right here. So if you guys have a really uneven surface, I mean, it doesn't matter if we're even going up vertical walls, that's kind of where the best route goes for doing that, that chamfer along there, or just to do a basic, deburr around there, if kind of doing that route too. So, any questions, guys, concerns, anything else you guys want to see, or more detail you guys wanted to see here? We had a lot of good questions come through here, and I definitely appreciate that, guys, because the more you ask, the more interesting it makes it, so. Especially when you guys like to stump me. But, all right, so it looks like we don't have any more questions. One thing I kind of want to, I know George is actually taking the test, but definitely come over and check out our certification program that we just kind of got going here. I know a lot of you guys are super busy with work and stuff, but if you guys have the time, I personally think it's a pretty fun test to take. It's the Certified SolidCAM Associates, very simple, just covering the basics of face mill, profile, drilling, tapping, reaming, that sort of thing there. Pretty simple part. And, really kind of testing your skills. We send you off a nice little certificate too, and you guys will actually be put on the website. We're actually coming up with a new website for this, and so you'll get to see who's been certified and all that stuff. So definitely I want to kind of point that out, kind of neat, something that we added in there. I think we're the only CAM company out there, and SolidWorks is the only CAD company out there that does a certification. So definitely come here, check it out. Or if you guys do have questions about it, shoot me an email. But, like I've said in the past, guys, these classes are solely dedicated to you guys. If there's something that you guys want to see, have questions, whatnot, please, I can't emphasize this enough, please send me an email right away, guys. And for those of you guys have sent emails, hopefully you got all your questions answered right away. And, even if you guys have, Ronnie, I know you work a lot of hours too. If you guys are working the weekends, you guys run into emergency, I want you guys to email me, because like I said in past classes, I want you guys to experience, SolidCAM or the support that you get from SolidCAM to be the best ever. So, if you guys have those questions over the weekends, shoot them over to me. As long as I do live up in northern Minnesota, so sometimes the internet connection isn't the greatest, but send those over to me, and we'll get those fixed for you right away. But I guess with that being said, guys, tell your friends. We'll give you, if they sit in a demo, we'll give you $100 Visa gift card, no questions asked. They buy the software. We'll get you 20% of that sale. So, Ronnie just wrote, upload was of no help to you tonight because working. Let's see. Was of no help to you tonight because working. Ronnie, I guess I'm a little confused at what you're saying there. Or maybe Ronnie was looking for help and I couldn't help him tonight because we were doing the night class. No. Okay. Thanks, Clarence. But yeah, definitely you guys just let me know what you guys want to see in there. And like I said, what we're kind of doing is getting through this HSM. So if we go into our 3D HSM here. Oh, thanks, right. He's saying he wasn't any help for me tonight because he was working. Ronnie has helped me out in the past with some of these. And the funny thing is, just like anything out there, you guys stare at something long enough, you can't figure it out, and then, a coworker, even you guys say, hey, check this, and then it's fixed. And I definitely do appreciate that. So, okay. So we did offset cutting and boundary machining. We're going to get into rest machining, doing a 3D constant step over. I really like using that 3D constant step over and the combine with constant Z, but we're going to get through all these in the next couple weeks. And like I said, I'm just trying to come up with, scenarios for you guys to kind of see, because there is so many different options inside HSM, and, kind of show you guys how everything kind of works. And hopefully I'm kind of getting that across going through these, one by one with each individual parts for you guys. So, and then we'll actually kind of carry it into HSS and going through all of the HSS modules, and then we're going to get into the fun 5-axis stuff. So from that, I guess, guys, I can't thank you enough for joining the night class and sitting through and listening. Hopefully you guys got something out of it, and like I said, I really do appreciate you guys coming here. It is take a lot of work to put these classes on, but it's personal enjoyment to be able to help you guys out. So let me know, like I said, what I can do for you guys to help you out also. So this video will be uploaded to the YouTube channel 1, 2 o'clock in the morning, depending on editing. And like I said, any questions, definitely ask away. And like I said, guys, I can't thank you enough for joining the class tonight, and really appreciate all the great comments you guys send over. So look forward to seeing you guys next week, and have a great rest of your week and great weekend, guys. And we'll talk to you guys next week. All right, guys, have a great night. Bye-bye.